Hi, I'm Christian Heckman and I'm a summer student here in the O'Reilly group at the University of Nottingham. And for my summer project, I work with a screen that can detect transaminases. So transaminases are a class of enzyme that catalyze this reaction, and it swaps an amine group and a carbonyl group around, essentially. And we detect that enzyme by using this amine, o-xylylenediamine, as the amine partner in the reaction. And when this reacts with the transaminase, you form this imine, which then tautomerizes to isoindole, which is unstable and polymerizes, and it forms a black polymer. And this black polymer can easily be seen, and that way we can infer that we have a transaminase, and we can actually feed o-xylylenediamine to whole colonies of cells, and they will then turn black if they have a transaminase. I'm going to show you how we actually do that assay in practice, and for that I initially need to plate bacteria, so I have bacteria to work with. And it is really important to work underneath a flame when you plate bacteria, because the flame sterilizes the air and prevents other bacteria that are in the atmosphere from falling onto your plate and contaminating the plate. And I'm also going to use ethanol to sterilize my gloves, which again prevents me from contaminating my plate. And then to actually plate my bacteria, I'm going to take some of a suspension of the E. coli, and I'm going to pipette it onto my membrane. And then I'm going to use the bacteria cell spreader to spread my solution all over the membrane so I get nice and distinct colonies. And growing my bacteria on a membrane allows me to lift them off later on, which makes the assay easier. So I have my bacteria here, and now I'm going to put them in the incubator at 37 degrees overnight. Now my bacteria have grown, and I can take them out of the incubator. So I have grown my bacteria, and now I need to induce them so that they actually produce the transaminase that I want. And to do that, I first lift the membrane off the LB plate and place it to the side. And then I pipette some of my IPTG solution onto the plate, and IPTG is a molecule that essentially tells the cells to start producing my transaminase. And again, I use the bacteria cell spreader to spread the solution on the plate. And then I take my membrane and put it back onto the plate. And now these have to go back into the incubator about at 30 degrees for 6 hours, and then my cells will have produced the transaminase. Okay, so here I have my plate from earlier, which I've induced, so they have now produced transaminase. And then I also have this plate, where I have bacteria that don't produce the transaminase as a control. And I have prepared plates that contain filter paper, which I've soaked in an o-xylylenediamine solution. And what I'm going to do is literally just lift off the membrane and place it onto the filter paper. And this now exposes the bacteria to o-xylylenediamine. And then we should start seeing a color formation fairly soon. Do the same for the control. Okay, and in like 20 minutes we should start seeing these go black. Okay. So it's 20 minutes later now, and as you can see, the cells that have expressed the transaminase have gone a greenish black, and the cells that have not expressed the transaminase have remained colorless. Okay, so this is how the assay works. I hope you enjoyed this video. Thank you for watching, and goodbye.